please welcome to the stage Soroush Khanlou.
I forgot my flare. All right. I don't know what floral shirt this is going to have to do. Hi, I'm Soroush. Before we get started, I just want to say thank you to the organizers. For a first-time conference, this has been incredible, and I've had a super good time, and it's been an honor to be here and see all these awesome talks and hang out with all of you fine folks. So I just want to give a small round of applause. So thank you. So I'm Soroush, and today I am here to tell you why you deserve nice things. Our story begins with this humble method on end string. It basically will tell you if one string is completely contained within another string. And the existence of the method or its signature is not particularly notable, but what I do find interesting is when it was added. This is something that every standard library probably should have. Whenever you want to work with strings, you're going to want to know if one is contained inside of another. And yet it wasn't added until macOS 10.10 and iOS 8.0, which is like, what, 3 years ago? And a string has been around since, the early 90s. And it was like up to 3 years ago we didn't have this at all. So how did we perform this functionality before we had this method? We use this method, range of string. And what range of string does is it looks very similar to the other method, except instead of returning a Boolean, it returns a range. And if you want to check whether or not your string is contained within another string, you call range of string, ask for its location, and then check whether that location is not equal to not found. Now, there are some native English speakers here and some non-native English speakers here. I think this is incredibly hard to read. The double negative in it is just very confusing. Not found, what does that mean exactly? And it just has a bunch of crap that I don't care about. And so I went sort of on a tirade about this, and I got this response from somebody who worked at Apple, name redacted, to protect the innocent. And they said that the Cocoa team tried to avoid adding API that might save a few lines of code here and there, didn't add a useful abstraction. Now, I think this is the wrong approach, and we're going to go into a little bit about why that is. But the way that we are supposed to solve this problem is that we're supposed to take this code that we find and we're repeating and stick it in something like this. This is a category in Objective-C known as an extension in Swift, and it lets us box up that code that we don't want to deal with and put it away and hide it away so that we can use it over and over again. Now, I don't think that this solution is satisfactory. And the reason for that lies here. If you go to GitHub and you search, and you see how many times is range of string being used, and you take a look at all of the different use cases of it. I've scanned through several pages of these search results. This is all open source code. And almost all of the results are essentially just using this method to detect whether the string is contained within the other string or not. So you can see range of string Canada dry, dot length is greater than 0. All that stuff is doing is just checking containment. And so range of strings is this really powerful tool that lets you do regular expressions, backward searches, critically insensitive searches, all this stuff. But most of the time, what people care about is whether or not the string is inside the other string. And so they added it in iOS 8, macOS 10.10, and now we can use it. Fortunately, this method bridges over to Swift as well, so we can use it in Swift. And I bring up Swift because Swift is not innocent here either. This is some code that this is a Swift 2 code, so don't try to compile this. It won't compile. And this is some code. This is the first extension that I would add to any project I started working on. So what this does is, given a sequence and some test defined by a block, it will return to you the first object that passes that test. And this is super useful. It's so useful that they ended up adding it to the standard library in Swift 3. And now I don't have to add this extension anymore, which is really nice. I don't bring up these two examples because it means that, well, Apple's got it back, and we don't have to worry about anything. They'll add stuff as they need to. The reason that I bring up these examples is because it shows that our world is not immutable, that we can affect it, and we can change it, and we can push for the things that we want, and the environment that we live in can change to better suit the way we want to code. And so one of the best ways to change that environment is to add these extensions and to make your code better in a lot of different ways, and we're going to go over some of those ways today. So the main thrust of this talk, what you're going to walk away with is you will know when you should add an extension. And to figure that out, I've come up with 4 rules, and I think if you follow these rules, you're going to make some really good extensions. All right, 4 rules. Cool. So rule number 1, I think this is the most important rule, is does the extension increase X Passivity? If you take away one thing, it should be this. If you pass this test, almost always it's good. If you don't pass this test, it's bad. So I want to look at a couple of examples of what X Passivity looks like and how we can sort of work with it. So here is a little snippet of code. I have this array, and it has 4 numbers in it, 1, 2, 3, 4. And what I'd like to get is the consecutive pairs of those numbers. So I want 1 and 2 to be together in a tuple, and I want 2 and 3 to be together in a tuple, and I want 3 and 4 to be together in a tuple. Now, before we talk about how we should implement this, I want to talk about some cases where it's useful. One situation is if you have a bunch of UI views, and you want to install a constraint between every pair of them, you would run this function, and your first 2 functions or your first 2 views will get 1 constraint between them, your second 2 will get a constraint between them, your third, and so on. This is a super useful way for constraining views to each other, and to do it, you need this sort of function that generates pairs. Another example, I work on an application called Urban Archive, and what they do is it's like guided walking tours around New York City with historical photos, and we have these paths for these walking tours, and they have waypoints on the paths, and we need to know what the total walking time is between all these points. And so to do that, we call each pair on our waypoints, and we get the ability to figure out the distance between each pair of those points. And so if we want to use the built-in tools of the Swift standard library to write this code, what that ends up looking like is this: zip a and a.drop first. Now, if you've seen this code before, you know what it does, but if you haven't, it takes a little bit of mental gymnastics to figure out what it does. So I'm actually going to show you. I'm going to do those gymnastics up here for you. So if we take a sequence and a sequence is drop first and zip them together, what happens, right? So we have our sequence for letters, A, B, C, and D. And we make a second reference to that sequence, which will essentially create a copy to it. We will call drop first on the second sequence, which drops that A. At that point, when we zip these 2 things together, anything that isn't in both sequences will be dropped off of the end. So we don't have to worry about that last thing. And then zip will pair our elements together and then give us one sequence with everything in it. So that's how this zipping function works. So if you see this in the code, the first time you see it, you got to do a little mental gymnastics and say, OK, well, you drop the first, pair them together, and drop off the last one. Oh, this is pairs. And the second time you maybe remember, oh, yeah, I've seen this before. What does it do? That's right, pairs. And the third time, you're starting to get pretty adept with it. And you slowly build up this mental alias in your head of what this does. And that is completely bananas. We have a way to generate the aliases right in the code so that you don't have to store it in your own head. And believe me when I tell you, you deserve nice things. So you can create an extension on sequence which will generate these pairs for you. And then when you go back to your calling code, you can just call each pair and get your pairs. This implementation that's on the screen does not work for single pass sequences, but it looks really good on a slide. If you want the single pass version, hit me up and I'll send you, it's like, I don't know, 20 lines of code. So it's a little bit more daunting. So you've got these pairs, and you'll notice now that you can use this in chains as well, so you can map, filter, call each pair, map again, do whatever you want. And it's a lot easier to work with than the previous code of zipping and dropping first. So not only is it easier to read, but it's also easier to work with. So let's look at another little code snippet. What does the second line evaluate to? Anybody just shout it out? 10. Bingo. You've got a mental alias in your head. For reducing 0 and plus, you know that means add up numbers together. And again, this is an alias in your head, and you don't have to live like that. You deserve something nice. Swift is very bountiful, so we can actually extend every single numeric type at once. So that includes all the integers, int 8, uint, it includes all the decimal number, NS decimal number, all the floats, CG float, double, everything, all at once with this one extension. So any sequence that contains any numeric number, you can now sum them. In Objective-C, we would write this as @sum.self, a key value collection coding thing. But this has the benefit of being compile time safe, which is even better. And Swift doesn't stop giving. You can also extend any sequence that has binary floating point numbers and get an average. So we use this in the same mapping application, Urban Archive. If we have a bunch of points and we want to know what the central point is, we will average all the longitudes together, average all the latitudes together, and generate something roughly in the center, and we know where we can put our map. So once we have that, our original code becomes so much easier to read, and anybody who comes along to our code base afterwards gets super nice code. So another one, I'm not going to make you try to figure this out in your head, but it's if an array does not contain things that do not pass the test. And if you put that on the screen, you definitely have to do some gymnastics to figure that out. But if I rename it and put an alias on it, you'll know exactly what this does at a glance. And so what that is this function tells you if all of the objects in a sequence pass a test. So quickly we can see that are all the objects greater than 0? That's false. Like, you can just tell that immediately. And so to implement that, we just basically check every element. If any of them return false, then we know that the whole thing fails. We can short circuit and come out of this. After first where was added to the standard library, this and its friends, which I will get to in a moment, is now the first thing that I add to a new project when I start working on it, because I know I'm going to need it. Next example, this one's a little bit simpler. If it does not contain an element where the element is greater than 0. Again, kind of hard to parse through. If you rename it to none, you know exactly what it does. Are none of the elements greater than 0? This is false. There are elements that are greater than 0. And implementation, also pretty straightforward, a little bit different from the last one. So we have all and we have none. Just for completion's sake, we can also add any. I won't belabor going through all this stuff, but it's nice to have a balance between any, all, and none. So that's the rule of if you should add an extension to a project. Does it increase expressivity? So that's the main thing you want to go for. So if you have that and you want to know more, second rule, does it decrease noise? So let's take a look at this. This is a problem everybody's faced in code bases. You've got an integer, let's say a number of rows, and you've got a height per row, and you want to know the total height. So what do? You multiply them together. And when you do, Swift quickly slaps you across the face and tells you binary operator star cannot be applied to operands of type cgfloat and int. Essentially, this is saying, I don't know what you're trying to get me to do. This doesn't make any sense to me. And everybody's seen this, and they know what to do. So you take the int, you wrap it in a cgfloat, and that constructs a new thing. Now they're both cgfloats. I can multiply them together, and Swift, the compiler, is happy. But this is all added noise. This is the 7 characters of cgfloat, the 2 parentheses. The reader of your code doesn't care about this stuff. They don't care about converting stuff. They know how it's going to be converted. All they care about is the one little exclamation point, or the one little asterisk right in the middle of those 2 things. What you can do about this, you can, because you all deserve nice things, you can overload the operators and say if the left-hand side is an integer and the right-hand side is a float, I'm going to handle it. And if the left-hand side is a float and the right-hand side is an integer, I'm going to handle that too. And now, every time you go to write this code, it just works, and you never have to think about, oh, which one do I need to wrap in a float? You don't have to worry about it. Your readers don't have to worry about it. Your life is nicer. I dealt with this wrapping of the cgfloat so many times that now when I write this code, I have a little flashback to like, oh, do I need to add the cgfloat wrapper? And I remember, it's like, no, it's already taken care of for me because I deserve nice things. So another one, let's talk about some more noise. I need 5 buttons. If you're familiar with Erica Sadoun, she gave a talk all about how to generate an array of 5 buttons. 30 different ways to do it in Swift. It's a great talk, super interesting. I'm going to focus on this one for now. Except what I want to know is, what are those? You don't have to live like this. That extra underscore and the extra in don't need to be there. Your user doesn't care about them. They're just visual noise. Nobody needs to see it. This is stolen from Ruby. Maybe you don't like this particular syntax. Maybe you think it should be done a different way. That's all fine. But you should have some way of generating a sequence of n voids so that you can map over it without having to see that ugly underscore. And so, maybe you like this implementation, this syntax. Maybe you like a different one. That's totally up to you. But you do deserve to not have to see that underscore. So that is some ways that your code can decrease noise. The third rule for determining whether or not you should add an extension to a project is a nice to have. You don't always have to get this. But if you can, it's great. So if you can sneak an optimization into your extension, every time you call that code, you're going to get the advantage of that optimization. So let's take a look at this. I actually think this one's pretty reasonable. Take my array, filter it for all the objects in 0, and tell me how many there are. You can kind of read this at a glance, unlike some of the other ones. But every time you call this, you're creating an intermediate array. That filter generates an array. You call count on it, get that count, and just throw the array away. We can definitely do better than this. So with an extension called countWhere, you can basically, instead of keeping track of an intermediate array, keep track of an intermediate integer. And every time an object passes the test, increment the integer by 1, and at the end, just return that value. And at the end, you end up with a function that's not only easier to read, not only simpler, but also is a little bit optimized. And for almost everybody, this optimization will never matter. But the fact is that when you use this, you'll never have to think about whether or not it matters and whether or not you should optimize it. If you're in a tight loop, it doesn't matter because you're already optimized. So that's one example of sneaking in a performance optimization. Another one, I really like this one. Let's say you're in Objective-C land. You have an array of letters A, B, and C. And you want to reverse that array. And your compiler's busy, and you're typing, and it hasn't caught up to you yet to tell you like what the autocomplete results are. So you type array reversed array. You're an expert. You've been writing Objective-C for a long time. You know that if this method existed, this is probably how it would be written. So you're going to take a stab and just assume that it's there. And when the compiler finally catches up with you, it tells you, no visible at interface for NSArray declares the selector reversed array. So what this means is, I can't find this function. I don't know what you're talking about. Try again. And so you dutifully go to Stack Overflow. How do I reverse an array in Objective-C? And it says, use this pattern. So you create a reverse object enumerator and then call all objects on that is the reversed array that you want. But there is a secret downside to using this function. And if we pause in the debugger right at that line of code, and we ask it, hey, reversed, what's your class? It'll say, I am an __ NSArray M. That M means mutable. And what that means is this is a full copy of our original array. So this took every single element from our original array and put it in a new spot in a new array. So what does that look like? If we had an array ABC, we make that copy as an NSArray M, and we move the last element to the first spot, the middle element stays in the middle spot, and the first element goes to the last spot. So we fully created a copy here when we call this reverse object enumerator.allObjects. If you go back to the debugger, and instead of using this code and calling the class on it, if you check instead, hey, why don't we just write that function and see what happens, and just call reversed array, this won't go through the headers. It won't check anything. It will just send the message to NSArray. And surprise, it returns something. This method is actually defined on NSArray, but it's not public, so you can't use it in your code. So Apple gets to use this, but you get to use this. And what it returns is an __ NSArray reversed. What does that do? That is a little bit different, and it's a little bit faster as well. So to take a look at that, we're going to examine the Swift version, which is open source. So Swift, now the conditional conformance has landed, we can use this called reverse collection. There used to be like reverse bidirectional collection or reverse random access collection. Now it's just one. It's great. So when you look at this reverse code, what it's actually doing is instead of copying each element to a new place in a new, all it does is it gently wraps the old array, and it returns to you a reverse collection that holds on to that original array. And when you go to ask for an element in that new collection, you'll say, hey, reverse collection, can I please have the object at index 0? And it'll think to itself, that's actually index 2 in the original collection because I know how to convert back and forth. And it will give you the element that you're expecting, and you say thank you. This is how message passing works. It's very polite. This optimization is available in Swift, which rules. Whenever you call .reverse, you get this for free. And now, instead of having to copy all of the elements in a potentially very large array every time you want to reverse it, you don't have to worry about it anymore. The system will handle it for you. So that is the third rule. If you can sneak an optimization into your extension, you're in really good shape. So the last rule is when I extend this class, does every single instance of this class need to get this method? And to explain, I'll give you an example. It's a little bit contrived, but you'll have to bear with me. You can imagine if you had all your information about a request in like a big dictionary, so you have like a key for your method, a key for your URL, your path, your all that stuff. And you had a function that turned that into some kind of rich request type. You can imagine that, well, it passes all the other tests. It's less noise, and it's more expressive. So I'll just put this on every NS dictionary, or every dictionary. The problem with that is that the purpose of NS dictionary, or the dictionary in this case, is not to hold on to properties for an arbitrary collection. For an arbitrary request. A lot of times, dictionaries are used for wholly different purposes. And so a little bit more appropriate code here might be that you pass it to a builder. The builder knows how to put everything in the right place and construct this request and give it back to you. And if you think this example is too contrived, this is something that I've actually seen in the App Store. And this extension doesn't do nothing. It's not bad, because it basically takes a dictionary from a push notification. You can tell because it's in the push notification category on NS Dictionary. And it takes that and it says, OK, I'm going to grab this key, and I'm actually going to cast it to an NS dictionary. So those are two useful things that it's doing. But at any given time, there's going to be lots of dictionaries flying around your app, and almost none of them have anything to do with push notifications. So this is not an appropriate place for a method like this. So that is the fourth rule. Does it belong on every instance of this type? Now, you'll notice there's one rule that is missing, which is it commonly used? And I actually don't think it's important at all for an extension to be commonly used for it to go into an app. I have extensions in apps that I haven't used yet, because I know that when I'm writing a new method and I have my fingers on the keyboard and I need a function that I know is not there, I don't have to ever leave that keyboard, create a new file, or go open an existing file, figure out where to put it, maybe write tests for it. I know that that extension's already there, and I can just type .e on my array, and it's going to get enumerated in each pair, and I'm going to say, I want each pair, thank you so much. So I don't actually worry at all if the thing is going to be commonly used. In fact, there's a bunch of objections I hear to this kind of behavior of creating all these extensions, and for every objection that you can give me, I can find an example that's existing in the Swift standard library today that fails that test. So if you want to say, oh, the method is too trivial, this is so easy to write yourself, I would point to this arcane piece of standard library trivia where this will give you an array slice with every element in the array in it. And the way that this works is completely bananas. It's like a custom operator that's ... and there's a special subscript that expects that function that returns it's crazy. But it works, and you almost never need it, but when you need it, it's there. Another one, if you've been following Swift evolution, SE 199, shout out to Christoph. There was a bit of a kerfuffle about this as well, of like, oh, you can't put a not operator there, like am I too stupid to put a not operator? And the extension provides a ton of value. And there's really, I think, nothing too trivial that we can't throw it in there. Another common objection, this is too esoteric. Who would ever use this? This is like some crazy stuff that would almost never be used. So that I point to sequence.lexicographically proceeds. This function can sort an array of characters as though it were a string by checking if each element compares to the next element. It's wild. I've never needed to use it. I've always wanted to use it. Never found a chance. But it's in there, and it's just hanging out, and I know that when I need it, it's going to be there. It's too specific is another argument I hear a lot. There's another example. It's partition by in the standard library on mutable collection. What this does is you give it a mutable collection, and it will swap elements until all the objects that pass the test are on this side, and all the objects that fail the test are this side. And it gives you the index right at which it flips, and you're allowed to use that to do whatever you want. It's useful for quick sort. Although the standard library sort doesn't really use it. It's useful for a couple other small things, but for the most part, this is really, really specific behavior that not a lot of people are ever going to need to use, but again, when they need it, it's going to be there. I want to talk about a few other odds and ends that I want to kind of throw in there. Here's one that is just baffling to me. It doesn't exist in the standard library. If you want to unique the elements in an array, you want to say, just give me the unique items. what everybody tells you to do, you go on Stack Overflow, how do I unique elements in an array? And they tell you, well, first put in a set, and then put that set in an array, and that'll unique them, obviously. And so you do that, you try to extract that to an extension, and you get this completely baffling compiler error. Generic parameter source could not be inferred. What this is actually saying is this is saying element does not conform to hashable, so I can't put it in a set. And this is true and fair, okay? So we'll say extension sequence where element is hashable only works there. But some elements are not going to be hashable by default. Some elements are not even going to be equatable. So how can we unique those elements? And another thing with this implementation, this doesn't preserve order. When you put things in a set, they could come back out in any order. And that's not necessarily what we want. So the way I like to do this is it works on all elements, doesn't have to be equatable, but you have to provide an equatability function. And if it happens to be equatable, then it will give you a default for the equatability, but you can always provide your own. And what it will do is keep track of a result array and loop through the current array. For everything that's not already in the result array, it will add it to the result array and then give you back that result, so you have unique elements. This is an O of n squared function, so buyer beware. You can also write a version that, hey, if it is hashable, use this other implementation where we will use a set so that it is actually O of n. So there's lots of interesting different things you can do, but they're all better than just stuffing it in a set and then turning that set into an array. Here's another one that I find myself doing a lot. You need to sort something, and it's not necessarily comparable. So let's say we have these houses, and we want to sort them by how many people live in them. And you write this code. Everybody writes it and goes about their day, and it works. But there's two potential places where you can get tripped up when you're writing this function. And one of them, I actually got tripped up when I was writing this slide. So that shows you how bad of a programmer I am. So one is you are calling the same. There's a little tiny bit of duplication in this function. It's not super obvious that it's happening, but it is there. And that's the fact that we have two objects, and we're calling the same property on both of them. So if you called the wrong property and they happen to be the same type or they happen to be comparable, then this function would subtly fail, and you wouldn't realize it. The other one is I can never remember what sorted by expects. Does it expect less than, greater than, which one is it? And then you have to option click on sorted by, and it tells you, well, I'm expecting a function called, what is it called? R in increasing order. And it's like, well, which one is that? And you don't know. So you might use the less than, you might use the greater than. The typo that I did was I called $0 on both sides, so it just didn't sort anything, which was great. So we can do a lot better than this. Like, we don't have to live like this because we deserve nice things. So if you use something called a property accessor, which returns some type T, as long as that type T is comparable, then we can just say this, we can just write this more terse code at the bottom, houses sorted on $0 dot number of residents. And that way, we don't have to worry about which operator to use. We don't have to worry about which, like if we're going to call the same thing on both sides of the operator, we don't have to worry about any of that. And the code is always going to work, and it's shorter to boot, which is great. I want to give a quick shout out. My friend Just Dave, who lives in New York as well, started this project called Public Extension. After a while, he stopped working on it, and somebody else took it over, Joe Fabisevich at MergeSort. And what Public Extension is about every week or so, they will tweet out, and they have like a mailing list, and they'll tweet out a cool extension that you can use. I contributed each pair to this little newsletter. So they're really cool. If you're interested in this kind of thing, definitely hit them up. Another one, you're dealing with push notifications, and you're like, I got to turn this data into a hex string. You used to be able to just call description, but that was really brittle and broke a bunch of people's apps. And every time you need it, you have to go back and look up, like, OK, what is %02HHX? Like, I'm never going to remember that. Like, I'm going to have to look it up every time. But if you have the extension ready, if the extension's in your project, when you need it, it's there for you. You don't have to suffer. Ruby's enumerable. Ruby's a language I steal a lot of inspiration from. They give a lot of rich things in their standard library. So they have functions for like greatest common denominator. There's like an is-even function on integers, which is great. A lot of their enumerable is like our sequence. So some of this stuff I stole from them. One example of that is chunking arrays. So if you're, let's say, sending a bunch of stuff up to an API, and you need it to go up in batches, you might resort to something like chunking. And this doesn't exist in the standard library. You got to write this one yourself. There are a number of different implementations. There's one I really like, but it's kind of too much code and too hard to explain for a slide, so I'm going to go with a simpler one. Grab the first n items off the array. If it's empty, you know you're done. Drop those same n items off of the same array, and then return the first bit plus a recursive function that calls on the rest of it. And this will give you the chunks that you want, and you don't have to worry about how do I write this code or go to Stack Overflow or any of that stuff. And if you think that UIKit is exempted from this, it is not. I've been ragging on the Swiss Standard Library and Foundation, but UIKit suffers from this just as much as anybody. This is a common one. I never know how to calculate aspect ratios. I don't know if it's height over width over height. First time I wrote this slide, I wrote it backwards. Apparently, it's width over height. And if you add this extension, you never have to think about it, and you always know how to get aspect ratios. Another one, I used to think that view controllers, I used to think that Apple didn't want you to know when a view controller was on screen. I thought that they didn't want you to rely on that state, and you had to use the view will appear, view did appear. Turns out you can totally rely on that state. It's there, but it's just not obvious how to get to it. So if the view has a window, and the window's not nil, that means that the view is in a view hierarchy, which means the view controller is on screen. There's a little optimization you can add here, which checks if the view is loaded before calling something on it. If the view hasn't loaded, it's definitely not on screen. So that's really nice, and you can check that state when you need to. Another one, I really love this one. This is the last one, strap yourselves in. You have a view controller, let's say, user's panning around with messing around with some data. New data comes in, and you need to cancel that user's touch. And so you type, pan gesture recognizer.ca, no auto-completion results, there's no cancel. So you go to Stack Overflow, how do I cancel in gesture recognizer? And it tells you, well, obviously, you set it to disabled, and then you set it to enabled, and that cancels it, obviously. And so you're like, well, the next developer that comes to look at this is going to be like, why are you setting to this thing and then back to this other thing? Is this idempotent? Like, what's happening? Do I even need this? Can I delete this? So you dutifully add a comment. This cancels any in-progress gestures. You don't have to live like this. You deserve nice things. You deserve a function called cancel on UI gesture recognizers that stores the old state of is enabled, sets is enabled to false, and then re-enables it if it was enabled before. And you can just write the nice code that you want to write, that you deserve to write. I'm Soroush. This has been Teki Con. Thank you so much, everybody.